Hello students. We are going to start things off by learning how to use Python as a calculator. So let's try that. Let's try starting off with our Jupyter notebook here. We have a nice little blank one here. What I'm going to do is I'm going to click in this window in order to get a cursor. And let's try to add 7 and 4. And in order to do that, what I'm going to do is I'm just going to type 7 plus sign 4. And then I'm going to hit Shift Enter. And what it does is it gives me the output, which is 11. We could similarly do subtraction. If we do, say, 7 minus sign 4, that's going to subtract 4. And Python is not scared of negative numbers. Minus 3 if I do 4 minus 7. Suppose I want to do 7 times 4. I could just do a star for multiplication. I could do something like 11 times 181, and that is 1991, the year that Python was invented. And then what comes next? I mean, we've learned how to do addition, subtraction, multiplication. Well, I know what you're probably thinking the next operation is, but there's an issue, because we might mean different things by division. Like if I say I want 7 divided by 4, what exactly do I mean by that? Do I mean I want, 7/4? Do I want a decimal approximation, or do I want a quotient and a remainder, right? Because 7 divided by 4 would be 1 with a remainder of 3. You could take out 4 and you'd have 3 left. Well, we can actually get either, but I want us to be very, very careful if we're not dealing with quotients and remainders. So far, everything we've done has to do with integers in Python, and all these whole numbers are stored in Python as this type of object, which is an integer. We'll talk a little more about types in a little bit. But Python has another type of thing that it can store numbers as, and that's as a floating approximation. And approximations, especially in mathematics, can be very bad. They're dangerous to work with. So we're going to try to avoid it. But if we have to get an approximation, what I'd do here for 7 divided by 4 is I'd use a single slash, commonly used for division, and I'd hit Shift Enter, and I get 1.75. And let me try that. Let's try 7, 4. Let me just do that. 7 divided by 4 minus 1.75. That's fine. Let's try something like 5 over 4. Okay, I'm getting some approximations. They seem pretty accurate. 5 over 4 minus 1. 0.25, okay. Let's do one more, 6 over 5, and let's try 6 over 5 minus 1. And now suddenly I get maybe not what I would expect. So when we're dealing with these things, these abstractions at this point in this class, which Python, which we're calling floating approximations, these approximations, Python has a very special way of storing them. And the way it's storing them is you could sort of think about it in your head as a mesh, where it has a way of looking at these numbers, and it's grabbing, it has a very fine mesh of little points, and it's grabbing a point that's close to whatever it is based on the way that number is being stored. This can cause all sorts of errors, so I'm going to give you a tip right now. Whenever possible, stick to integers and avoid floats, especially when doing mathematics. We do not want rounding errors. We do not want unexpected things like what we saw here to come up. Okay, but what if we want good old quotient and remainder division? That gives us integers. So in order to get that quotient remainder division, what we could do is we can use a double slash. So I could use 7 double slash 4. That gives me the quotient, which is 1. And for the remainder, what I'm going to do is I'm going to use the modulus operator, which is the percent sign here. And I do 7 mod 4, or modulus 4, and I hit Enter, and I get the remainder of 3, which is exactly what we would expect. Now, some of you may know more about modular arithmetic than others at the point where you come into this class, based on what classes you've had before and what math you've seen already. So depending on what you know already, you might think of modular arithmetic in a very special way. I'm going to show you guys the comment sign. See that little number sign? If I do that, then Python's not going to execute this. This is a comment. And I can hit Shift Enter and it's not going to give me any output, which is exactly what I want. Because in modular arithmetic, let's say I'm talking about numbers mod 4. In that case, we say that two numbers are the same or congruent if they differ by a multiple of 4. So in that case, if I wanted 7, well, it would be the same as any number that differs by a multiple of 4. So 7 would be congruent to 11, but also congruent to 3. 11 and 3 would also be congruent. All three are congruent because 11 and 3, well, they differ by 8, which is a multiple of 4. So you might know this, and if you don't, that's okay. This is just a side note for people who know modular arithmetic. So what the modulus operator does here is it gives us the smallest non-negative representative in the equivalence class of all the numbers that are congruent. So in this case, if I wanted, say, 7 mod 4, it gives me the 3 if I want 11 mod 4. Since 11 is congruent to 7, is congruent to 3, it's going to give me 3. And why 3 instead of 7? Well, because 3 is the smallest non-negative number that is equivalent to 11 mod 4. And we can dip into the negatives too. If I wanted to do -1 mod 4, which should be equivalent to 3, it will also give me 3, which is the smallest non-negative number that is equivalent to -1 mod 4. So for those of you who know modular arithmetic, you could think about it in two different ways. You could think about it as grabbing the least non-negative number from the equivalence class of all the numbers that are equivalent to it, or if you just want to keep things with quotients and remainders, you could think, hey, 3 is the remainder when I divide 7 by 4, or when I divide 11 by 4, or even when I divide -1 by 4. Because remember, remainders can't be negative. So if I take -1 and I divide it by 4, and Python will even know how to do this, I get -1 with a remainder of 3. Because -1 would bring me to -4, and then I'd go 3 to the right to get to -1. Okay, so this gives us an introduction to addition, subtraction, multiplication, and division, and we have more operations to deal with. You know what? Let's squeeze one more in right here. Let's do exponentiation. So if I want exponentiation, say I want 2 to the 4, I'm going to use a double star. And that's the operator for exponentiation. And I can actually get quite big, not 2 times 300, but 2 to the 300th power. Python is not at all scared of big numbers. And another thing that you should know about Python that makes it different than some other programming languages is that it has infinite integer precision, or as big as you can get. So as long as Python can compute it in a finite amount of time, and your computer doesn't keep running for the calculation, and as you see, Python's actually very good with big things, but as long as it runs and gives you an integer answer, you know that integer is correct. There are some programming languages that what they'll do is similar to floating approximations. If integers get big past a point, it'll say, okay, there's this big number, but it's close to that big number, so I'm just going to round this big number to a different integer. Even though there's no decimals and there's nothing like it, it'll say, okay, I'm going to replace this big integer with that big integer. Python will never do that. So if you get an answer which is an integer, then in Python you can always be sure that it has not rounded that to a different integer. That integer is the correct integer no matter how many digits it has. So even if it's a very long thing like we have here, you can be sure that that integer is correct. And I guess that's all for now.